Okay, welcome to Geometry Week 2. On our agenda today, we have a bunch of things, being very ambitious this week. We're going to be covering triangles, mostly congruence and similarity, do a rough overview of polygons, kind of just a definition. We're going to learn some perimeter and areas, mostly related to triangles. We're going to do a quick introduction of proof that coincides with the congruence and similarity. And I don't think we'll have time to get to it, but I'm hopeful that we'll be able to start constructions today. So, last week, I feel like I had a lot of fun with the rubber duck. How was your week scale? So today I got a shaggy scale up. I'd put myself at probably an 8. I'm chilling today, having a pretty good time. How are you guys doing? Very nice, Anna. Very nice, Alex. I guess all of these are kind of negative feelings, but if you're having a great day, then I'm happy for you guys. Very nice, Eleanor. Couple 3s. I love rain too. It's so calming. Sometimes I listen to rain sounds at night. Okay. A 2. I feel like a dog too sometimes. Okay, let's get into polygons, guys. So you guys have probably heard of a lot of polygons. These are like the common names for them. We typically name polygons based on how many sides they have. A polygon is any figure that's described by a finite number of straight line segments. So that means that nothing with like a curl, so nothing like this like half circle thing is a polygon, and especially not since this actually has an opening there. So polygon has to be completely enclosed, and it has to be made up of only straight line segments. So right there is a pentagon. You might notice all these shapes I have here in this image are regular polygons, which means that all of their side lengths are the same. But that's not the only polygon that exists forever. However, this is a regular quadrilateral, but you could have a shape like, not like that, a shape like this, that would also be a regular, an irregular quadrilateral because it has 4 sides. So the polygon that we're focusing today on is triangles. So let's do some stuff with the area and perimeter of triangles. So the area of a shape is just the total amount of space that's enclosed within the shape. You guys have probably done some basic area problems. The formula for finding the area of a triangle is 1/2 base times height. On this triangle, the base would be this side right here. It's kind of the side that just like sits on the ground kind of. And the height would be 6 feet. So that side over there. So the height is like a straight line from the bottom of the triangle to the highest point. So in this case, if we were to calculate the area of this triangle here, we would get 6 feet times 15. That's like a time symbol. We could also say 6 times 15. And then we would divide that by 2, which is the same thing as multiplying by 1/2, which is, let's do some math. That would be 3 times 15, which would equal 45. So this triangle here is 45 feet squared because it's like a 2-dimensional space that we're measuring. The unit we add is whatever unit that we're measured in, and then that unit squared. I don't think units are really that important. I tend to not get as confused as a lot of teachers feel that units are important. You know, like, what are we talking? 45 pigs? But I don't know. I don't think that's a big deal. Usually know what you're talking about. So in this example, you see sometimes you kind of have to get creative with how you draw your triangles. Because if we didn't know that this area here was 10 feet tall, we would like have no idea how to find the height. Because like you can't draw the height from here to here because that's not a straight line. Well, it is a straight line, but it's not directly the shortest path from the top to the bottom of the triangle. But in this case, we do have this dashed line. So just use this. 14 feet is the base, 10 feet is the height. Use this formula right here. I want you guys to try to calculate the area of that triangle and throw your answer in the chat when you're done. You can have a little mini race. Okay, cool. Thanks, guys. Got a couple 70s from Daniel and Anna, and that's right. So we would have 10 times 14 divided by 2, which would be equal to, we divide these, 10 times 7. Oops, I was just about to write the 7. 10 times 7, which is equal to 70, and it'll be 70 meters squared. Cool. So let's get into a little perimeter, shall we? So perimeter is just the sum of the side lengths which enclose a polygon. In the case of triangles, you just add the 3 sides to 3 side lengths. So for this triangle, we would add this side length, 6, and then we'd add this side length, 15. And then we'd have to calculate the length of this side. Now for this, I don't know if you guys have used the Pythagorean Theorem yet, but this is a way to calculate the side lengths of a right triangle, which we have here. You've probably heard of it. Basically what it says is the longest side of a right triangle, which is called the hypotenuse, is equal to the square root of the squares of the other 2 sides. So in this case, this side here would be equal to square root of 6 squared plus 15 squared, which I think is around 16. I'm not going to do an exact calculation because I don't have a calculator offhand. I guess it would be on hand. Root 61, 261, if anyone can calculate that. I think it's around 16. So the perimeter of this triangle here would be 6 plus 15 plus square root 261, which is not exactly a nice number, but that's what it is. So I'd like you guys to go in here to this triangle and sort out what the area is and what the perimeter is. And yeah, through your chat answers in a chat. You can do a direct message or to everyone, really doesn't matter. Yeah, so yeah, find the perimeter and the area, both of them. Cool. Thanks, Timothy, for the answers. Would you be comfortable in walking us through how you got to those answers? I'd love to hear your thought process.
Okay, so I did 11 times 13.4.
Yep.
And I got 147.4.
Nice.
And then I divided by 2 to get 73.7.
Great. That's exactly right. I'm trusting your calculator because I don't actually know the answer. Okay, yeah. Perimeter.
And for perimeter, I just added 15, 14, 11, and I got 40.
Nice. Super great. Okay, that's really awesome. Thanks, guys, for participating. Okay, so I'm not going to spend too much time on area and perimeter. We've got a little more fun stuff to be moving on to. It's kind of basic once you get the gist of it. So let's move into congruence. So what congruence is it's basically when you have two shapes that are the same, and all you need to do to like prove that they're the same or to have them like sit exactly on top of each other is rotate one or transport one or, you know, shift it over somehow. So when you have two shapes that are congruent, we know that all the side lengths of the shapes and all the angle measures of the shapes are the same. So for example, these two triangles, if we know that these two triangles are congruent, then we know that these lines are the same, and that we know that these lines are the same, and we know that these lines are the same. So they all correspond to each other. And we know these are congruent because we could rotate this triangle like this way and then move it over and they would sit exactly perfectly on top of each other. And the other thing we know is we know that their angles are the same. So in this case, we know that these two angles are the same. We know that these two angles are the same. And we know that these two angles are the same. So there's a lot of problems that we can kind of do with these things. So first we should talk about notation. When we write triangles, we mark them with a little triangle symbol on the left side. So let's say we have this triangle right here. Let's call it ABC. I'm going to copy paste this. I'm going to rotate it a little bit. Oops, kind of changed the size. But let's call this triangle DEF. It's a really great D and F. So because we know these two triangles are the same shape, all I did was copy it and rotate it a little. We know that they're congruent. And then we write it like this. We write triangle ABC is equal to, with a little squiggly line over it, triangle DEF. And then that reads like triangle ABC is congruent to triangle DEF. So let's get into some types of congruence. These are the four different kinds, four different like methods of proving that two triangles are congruent. So the letter S always stands for side and the letter A always stands for angle. First method is SSS or side, side, side. Second method is SAS, side, angle, side. Third method is angle, side, angle. And fourth method is angle, angle, side. So the SSS congruence method basically tells us that if all three side lengths of two triangles are exactly the same, the corresponding side lengths are the same, that means that the two triangles are congruent. So in this example here, we have triangle ABC and we have triangle XYZ. And we want to prove that these are congruent triangles. So we want to prove that they're the same, and all we have to do is rotate one over, and then they'd be exactly on the same, in the same position. And to do that, we can use SSS congruence because we know stuff about their side lengths. So here, we know they give us that angle line segment BC is equal to line segment YZ. So we can write that down because whenever you prove something, it's important to write down everything you know, just so you have like a bank of information, because they'll give you everything you need to do in a problem. We know that these line segments are equal, and we know that these line segments marked by the double hash marks, line segment AB, we know it's equal to line segment XY. We also know line segment AC is equal to line segment XZ. So with these three things, now we can rely on our SSS congruence theorem to prove that these triangles are congruent. So I wrote it out here. We know that all the corresponding line segments are equal. Then by the SSS congruence method, we know that triangle ABC is congruent to triangle XYZ. So that was a pretty elementary proof, but it was the first proof we've done so far. So I think that's pretty cool. We can use congruent triangles for a lot of things, including finding angle measures. So in this practice problem, which asks us to find angle MLN right here, you might have a couple ideas kind of on how to do this problem. And one thing that we learned last week is when you have two parallel lines and you cut it through with a line, then these two angles would be equal. So it would make sense logically that this angle here would be 25 degrees. The thing is, we're not told that line segment LM is parallel to line segment ON, so we don't actually know that these are parallel. So we have to rely on some other method of finding this angle MLN right here. And a way that we can do that is with congruent triangles. So does anybody have any idea on how we would find the angle MLN? Go ahead and raise your hand because I'm interested in seeing who has some ideas. Anna, do you want to talk us through what you're thinking?
Yeah, if these are like congruent triangles, you could know that angle L is 25 degrees because they're congruent, and if you put them congruent, the 25 degrees is gonna be like right there where the mark is, so you know that's 25 degrees.
Yeah, exactly. If we know that these two triangles, triangle LMN is congruent to triangle LON, then we know, because these two are the angles that correspond to each other, then we would know that angle MLN is equal to 25 degrees. But the thing is, we're not told that they're congruent triangles yet. So in order to prove that they are, we can use the lengths of the sides that are given. So here, we're given that side length MN is 9. I don't know what unit, it's just 9. And then we know that side length LO is also 9. So let's write that out. Line segment LO equals line segment MN. And and we also are given the fact that this segment LM is 17, and this segment ON is 17. So we know that LM is equal to ON. Now from this, we have written out there two of the three necessary lines to prove that two triangles are congruent with Sss congruence. And the thing is, we actually have the third line kind of just obviously given to us right here. This line, LN, is shared by both triangles, LMN and LON. So we know that line segment LN is equal to line segment LN. And thus we have these the three building blocks for our proof. So what we say is we know that, whoa, I can totally spell. We know LO is equal to MN. We know that LM is equal to ON. We know that LN is equal to LN. Thus, triangle LN M, I messed up the order there, is congruent to triangle LON. And from that, because these are corresponding angles, we know that angle MLN is 25 degrees. Cool. So I hope you guys are all following along. It's kind of a new concept, I imagine, for some of you, but some of you probably, getting it completely. So I want to give you a chance to work through a practice problem on your own. Please ask me questions in the chat if you're confused at all, and advocate for yourself, because if you're confused, literally everyone else in the room is confused. It's just a fact, and they're just too scared to kind of speak up for themselves. So I'm gonna give you guys like 5 minutes, try to work through it, and then I'll call on some people to explain. Anna, do you still have a question?
Yeah, so for example, in this diagram, there's like angle ABD. How do you know like which angle it is? Because there's 3 angles.
Okay, yeah, I see what you mean. So when we write angles, we write them in like the order that they're defined, if that makes sense. So the point that's at the vertex of the angle is always the middle letter in the angle, in the written out version of the angle. So angle ABD would be this angle right here. Oh wait, I think I messed up, guys. Sorry. The problem is being a little confusing. Anna, that's a very good question. I think, okay, sorry guys. Yeah. So the angle ABD here would be this angle right here. It goes from A to B to D. And then this angle CBD would go from C to B to D. So yeah, when we write out angles, you kind of connect the dots from the 3 points that are given. So yeah, prove that those two angles are equal. And there's not a line connecting B and D, so it's also a little confusing, but yeah, I'll give you guys a couple minutes. I'm gonna turn my camera off because I have some yummy chicken katsu that I'm gonna eat. Okay, guys, I hope everyone had a chance to sort of think about the problem. I'm gonna call on someone new today. Does anybody have any ideas who hasn't shared yet of how we might prove these angles are the same? How about Justin? I haven't met you yet. I'd love to hear your thought process. I don't know. Do you have any ideas?
Let's see. I mean, if you to prove that ABD equals CBD, well, you can split the shape from up and down, so horizontally, and then since the sides, so because the sides are all AB equals 7, and then CB equals 7, and then AD equals 4, then DC equals 4, then they're the same value.
Yeah, perfect. Perfect. So we know that line segment AB is equal to line segment BC, which is equal to 7, but honestly, that doesn't really matter for this problem. And we know that line segment AD equals line segment DC. We also know that line segment DB is equal to line segment DB. So from this, we now know that triangle ABD is congruent to triangle DBC. And then from that, we know that these two angles, ABD and CBD, are the same because they correspond to each other. Okay, thanks so much, Tristan. I meant to put the emoji there that's like a finger pointing out, but it didn't transfer over when I put my slides into Notability, which is kind of a shame. But yeah, congrats on your first proof. Let's get into some more congruence methods. I'm gonna try to speed run these as much as I can. First, we have side angle side congruence, pretty self-explanatory. When we know two sides of a triangle are equal and the angle between them are equal, then we know the two triangles are congruent. So for example, here, we know that line segment CB is equal to line segment ZY. We know that line segment CA is equal to line segment ZX. And we know that these two angles, angle ACB and angle YZX, are equal. So then we know that these two triangles are congruent. So let's work through a real quick practice problem here. So this point E, is the midpoint, which means it's kind of just the meaning is in the definition. It's exactly in the middle of, what did I say? Meanings in the definition? I think I meant definitions in the word. So E is exactly in the middle of A and C, which means that these line segments, AE and CE, are equal, which is also given to us. And we want to prove that AB is parallel to CD. So we can do this with congruent triangles. So we start off with what we know. We know that line segment AE is equal to line segment EC. We also know here that line segment BE is equal to line segment DE. And the last thing we know, if you remember from last week, angles that are opposite of each other in intersecting lines are always the same. So we know that angle AEB equals angle CED. So from this, by side angle side congruence, we know that these two triangles, let me actually write this out like a more formal proof. So by SAS, triangle AEB is congruent to triangle DCE. So now let's go back to what the question was asking us in the first place, which is prove that AB is parallel to CD. If you remember from last week, when two lines are parallel to each other, then the angles that form here, which are called alternate interior angles, are the same. This also works conversely. So if we know that these alternate angles are the same, we know that these lines are parallel. And we actually do know this because we just proved that these two triangles are congruent, which means that these two angles, which correspond to each other, are the same angle. So let's write that out. Angle EAB equals, I don't know the angle, angle ECD. So therefore, AB is parallel to CD. Okay, hope you guys all followed through my chicken scratch handwriting. Without further ado, let's go on to angle side angle congruence. So angle side angle tells us the same thing that SSS and SAS tell us. It's that if two triangles have the same two angles and share a side that's equal in between them, then the two triangles are congruent. It's important to note that the order of these congruence theorems kind of matters. Like, basically, for this one, the angle that they share has to be in between the two equal sides. And for this one, the side that they share has to be in between the two equal angles. So yeah, that's basically the formal definition. Oh, sorry. So angle side angle kind of correlates with angle side congruence. Actually, the angle side congruence theorem is derived from the angle side angle congruence theorem. We're not going to get into that because it'll take too long. But yeah, angle side is basically when you have two angles and then the side not between them is the same. Then you know that those two triangles are the same. I had a couple practice problems here. This one is a little trickier, but I know you guys can get it. I'm going to give you like 3 minutes, maybe 4, and I'm going to call on one of you guys, hopefully, and we can get some interesting thought processes. Okay, guys, does anyone have some thoughts they'd like to share? I actually just solved this one along with you guys. Anna, what are you thinking?
So I can prove the triangle ABF is congruent to triangle CDE because angle A and angle D are the same, and
Yes.
angle B and angle E are the same, and also line BF and line CE are the same. So since that has two angles that are the same and one line that is the same, that means they're congruent.
Yeah. So what theorem would you be getting that from if you have two angles on one side?
That would be, I'm pretty, what would it called again? AAL, I think.
Yeah, it would be AAS. Gorgeous. Thank you so much. So yeah, exactly right. We know angle A is equal to angle D because of this. We know that angle B is equal to angle E. And Anna just skipped right to the chase on these two, but the longer, more in-depth way of proving that line FB is equal to line EC is by saying that FE equals BC, right? And we know that EB is equal to EB. So FE plus EB is equal to FB, and that is equal to CB plus BE. So yeah, basically if you just add these two to the whole thing, they're the same. And then they're congruent by angle, side, because you have two angles and then one side shared. and the side is not between the angles. Okay, cool. So I have a really quick practice problem. Work through this by yourself. I don't think we're gonna talk through this one. I'll give you like 2 minutes. Just go through and see which ones are congruent and justify them using like the specific congruence method. Okay, cool. I hope you all got a chance to work through that. Let's move on. So I'm not going to say this, but I'm sure some of you were wondering, I sure was, is there a side-side angle congruence theorem? And unfortunately, there is not. And the reason being, I have this cute little image here showing that all these triangles share 2 side lengths and an angle that are the same. In this case, it'd be these. They're all marked. However, these triangles are obviously not congruent. I guess these two, it's a little less obvious that they're not. But the reason is when you have these 2 side lengths, the way you can draw the third side can vary from being like really short to being really long. So unfortunately, it's not a congruence theorem. And I made the mistake of thinking it was a similarity theorem, but it's not. But that is a nice segue into similar triangles. So similarity is when one object is the scalar multiple. So it's the same as another object, except it's shrunken or it's like expanded. So for triangles, it just be like a triangle and then one that looks like the same shape, except it's kind of a little smaller or a little bigger. And those triangles that are similar will share the same angle measures. As you can see here, all the corresponding angles are the same. It's just the side lengths are not the same. The thing is, though, they are scalar multiples of each other, so they all have the same ratio. So I'm going to use an example. Let's pretend that this triangle here is 2/3 the sides of this triangle here. And this side length is 9 centimeters. Then here, this side length would be 2/3 of 9, which is 6. So the side lengths are proportional and the angles are the same. However, the side lengths are not always the same. So there are a couple methods of proving similarity too. There's the angle method, there's a side angle side method, and side method.
No.
So first, let's get into angle similarity. That tells us that if two triangles share 2 corresponding angles, then the triangles are similar. So in this lovely image to the right, these 2 triangles share the angle measure 50 and 60. From that, we know that the 2 triangles are the same. And at first I was like, well, can't you prove that triangles are the same using all like an angle method? Like, why do you only need 2? And that's just basically because if you have two triangle angles that are the same, the third one is always going to be the same because there's only 180 degrees in a triangle. Okay, so I have a practice problem using similar triangles that's going to get into angles. So the goal here is find BC and DC. So that would be this line segment here and this line segment here. Okay, So I might actually need some help with this problem because I've never looked through it yet. But basically, the gist of it is that we know this side length here on AD is 3. Hold on, I'm going to erase this. And we know that this side length here is 5. So let's see, AD over AB is equal to the ratio 3/5. And so yeah, that'll be helpful later in finding the side lengths of this triangle. Let's focus on the angles because we're dealing with angle similarity. And I noticed that we have 2 right angles here. So we have 2 right angles. Angle CDB is equal to angle, what would that be? ABC. So we already have 1 angle. So we're 1 step closer to proving that these triangles are similar. And I think that the second step in proving that, which would be this angle, because just like when we learned about congruence and 2 triangles share the same side, these 2 triangles share the same angle. If you look at ABD kind of flipped like this, then this would be the angle I have highlighted, which is the same if you correspond it with this angle. So yeah, angle CAB is equal to angle DAB, I guess would be the corresponding one for the small angle. So we know that 2 angles of these 2 triangles are the same. And from that, we know that these are similar triangles. So the notation for that is triangle ADB is similar. It's like a little squiggly line to triangle ABC. And we already found this ratio of the side lengths, which is 3/5. So to find BC and CD, it's just a matter of using our ratios. So yeah, I'm actually going to give you guys 2 minutes to work through this, just to finish this off, because I have a little emergency that's just popped up. So I'll be back. Sorry guys for that. I think I'm going to move on from this problem to another one using angle similar triangles. It's going to be the same kind of thing using the ratios of the line. And the problem is to find RS, this segment here, using these 2 angles and this angle. So yeah. Okay, sorry about this, but I need to speed run the rest of these. So angle is gonna say goodbye for now. We're gonna move on to side angle side similarity, which tells us that if 2 side lengths of a triangle have the same ratio and they share an angle between them that is the same angle, then the 2 triangles are similar triangles. So here we know that line segment AB is 2, line segment DE is 4. So 2 to 4 is a ratio of like 1 to 2. And we know that side length AC is equal to 3. And we know that side length DF is equal to 6. So the ratio 3 to 6 is also 1 to 2. And they also show this angle 60 degrees. So by side angle side, we've proved that these 2 triangles are similar triangles. So here's a little practice problem. In this case, we'd use the fact that, we'd use the fact that this side here is 12. But this entire side length here from A to E, this side AE is 12 plus 3, which is 15. So the ratio of AD to AE is equal to 12 over 15. And that simplifies to, I think, 4 over 5. Okay, so let's use that here on this side, where we'd have line segment AB, which is equal to 8, and the ratio of that to AC, which would be 10, is also 4 to 5. And we know that this angle here is shared by both of the triangles. In this case, in the smaller triangle case, it would be angle DAB, and in the larger triangle case, it would be angle EAC. So by side angle side similarity, we know that these two triangles are similar. Okay, so side similarity. This basically tells us that if we know 3 sides of 2 triangles have the same ratio, then they are similar triangles. And so once we know that they're similar triangles, we know all the angles are the same. So in this case, the ratio is 1 to 2. Line BC is 4, and line FE is 8. So that corresponds. And line CA is half of line FD. Line BA is half of line ED, 7 to 14. So by SSS similarity, we know that these two angles are similar triangles. Sorry, these two triangles are similar triangles. So I have this practice problem. It involves a bit of parallel lines. Remember that if you have 2 angles that are the same and their alternate exterior, they correspond, then the 2 lines are parallel. And the problem is prove AE is parallel to BC. You only have to do that part. This part here is kind of extra, but it kind of just falls into place once you have it. I'm gonna give you guys like 3 minutes, and I'm gonna save some time because I've made another Kahoot that we're gonna do. Okay, guys, I hope you had some time to think through that. I don't think we're gonna have time to work through it because I have a final challenge for you guys. If you guys can complete these two problems by next week, I'll give you a tour of my Minecraft mansion. And I think it's pretty cool, even though I've never actually beaten like the game, except in creative. But yeah, feel free to screenshot or take a picture, and then we're gonna move straight into a Kahoot. I'll give you guys a couple seconds. Okay. I'm actually gonna stop screen sharing really quick because I don't have the Kahoot queued up at the moment. Be right back. Oh, actually I do. Wonderful. Justin, you can do it. Actually, yeah, if you need like any help, please email me. We can do like a private Zoom session, anything, you know? And anytime during the week. I don't check my email like too often, but I will get back to you. Okay, let's get this started. Classic mode. I kind of like the spring theme. Why is the pin not loading? But the flowers on the bee is super cute. It's gonna show up. I believe in it. I believe in my internet. Let's go. Okay, I'm reloading. App that says hello. No. Oh my God, yeah, I'm in Chinese. I'm learning Chinese at my school. It's really fun. It's the Ni Hao app. I like that. Cool. I'm also Chinese. You might not be able to tell, but I'm trying to reculture myself, you know, because I'm only half. I hope this will load. But yeah. Anna, do you use the Ni Hao app? Wait, Daniel, are you Chinese? Oh my God, why is this not loading? Nice. Yeah. Well, this unfortunately is not loading. So that is really too bad because I had like some fun questions on there. I might be experiencing, oh, there it is. Might be experiencing some mild internet problems. Sorry, that's an occupational hazard of the. I'm not showing you guys until you finish the problems. But I'll give you guys a couple extra minutes. I actually kept you guys over last time, so I can let you go a couple minutes early. Well, if you like solve it and email me the answers and not everyone does it, I can like send you some.
Here's a thing for solving internet problems. If you're using a laptop and you have it plugged in, it can be glitchy sometimes because I have experience that while playing Minecraft. If you have it plugged in, it can be glitchy.
Yeah, I think so too. Yeah, thanks, Anna. I don't even know what's happening. I'm on my iPad right now, actually. But thanks. Let's see if it'll load on my phone. Okay, guys, it loaded on my phone if you guys want to join. The code. Okay. Okay, Justin, don't tell anyone. Keep it a secret. Okay. I'm going to send everyone the code, and then maybe we can do like the first couple questions. Want to join? There's some that like require to see the photo, and might not be able to do those, but no, we can try. I can just tell you the answers. Hey, Alex, thanks for joining. Actually, let's see if I can join. No, I can't. Okay, I'm just gonna start. You can't see it. This is the best we're gonna get. Can you guys see that? Okay, I'll just tell you the answer. It's 15.5, it's blue. Literally, it's so hard to see. Everyone answer blue. Oh my God. I'm sorry, guys. I'm having too many internet problems. I kept you guys like over a couple minutes last time, so I think I should end this right here. Thanks so much for coming to week 2. I can't wait to see you next week. Send me the answers to your problems and have a great week. Thanks so much, guys.